All right, I'm going to just start with the very basic Chebyshev's theorem and the empirical rule. Chebyshev's theorem says that if you do 1 minus 1 over the standard deviation squared, multiply it by 100 to change it to a percent, you can figure out how many percent is within a certain number of standard deviations. The empirical rule is just pretty straightforward. It says that 68% of the material will be within 1 standard deviation, 95% within 2, and 99.7 within 3. And so when they talk about that, they're talking about having your normal curve and that your mean is in the middle, and 1 standard deviation would be going 1 in each way. So if I said that was 1 standard deviation there, you'd also have 1 standard deviation over here. And the farther out you get, obviously, the more of your area is going to be underneath your curve. So the first example here is the easiest probably form of this problem. It says there are dozens of personality tests available on the World Wide Web. One test scored on a scale of 0 to 200 is designed to give an indication of how personable the test taker is, with the high score indicating the more personability. Suppose the score on the tests have a mean of 98. Complete the following statement about the distribution of the scores on this personality test. So according to Chebyshev's theorem, at least what percent of the score lies within 2 standard deviations of the mean, which of 98? And it gives you the choice of 56%, 75%, 84%, and 89%. So in this case, all we're going to do is use this formula up here. I just start with the part in the parentheses, and then I change it to a percent. So if I'm looking for 2 standard deviations, I'm putting 2 in for K. So I am going to do 1 minus 1 over 2 squared. If I do that, I would have 1 minus 1 over 4. And if I take 1 minus 1/4, I would have 4/4 minus 1/4, which is 3/4. And 3/4 as a decimal is 0.75. Then when I take it times the 100, that means I'm going to have 75%. So 75% would lie in 2 standard deviations. The second part of that is using your empirical rule. It says, suppose the distribution is bell-shaped. If approximately 68% of the score lies between 75 and 121, then the approximate value of the standard deviation for the distribution according to the empirical rule is what? So I'm thinking about my standard normal curve. I know that 68% would be 1 standard deviation each way, and so my n numbers are 75 to 121. So what I'm going to do with that is, first of all, subtract those 2 numbers. And so if I take my 75 minus my 121, I've got to grab a calculator here. Or actually, I'm going to do it the other way around. 121 minus 75 is 46. So between here and here, it's 46. If I do 121 minus 75, I get 46. So if I take my 46 then and divide it by 2, because I have 2 sides of my mean, I get 23. So since I'm just looking for 1 standard deviation, I'm saying it's 23 on each side. So according to the empirical rule, 1 standard deviation would be 23 when I do that. Okay, so now we get to the next longer version of the Chebyshev's theorem. It says Loretta, who turned 80 this year, has just learned about blood pressure problems in the elderly and is interested in how her blood pressure compares to those of her peers. Specifically, she is interested in the systolic blood pressure, which can be problematic among the elderly. She has uncovered an article in Scientific Journal that reports that the mean systolic blood pressure measurement for women over 75 is 134.8 with a standard deviation of 6. Assuming the article reported correct information, complete the following statements. Complete the following statements about the distribution of systolic blood pressure measurements for women over 75. My printout printed into my words. So, first part of this says, according to Chebyshev's theorem, at least what percent of the measurement would lie between 122.8 and 146.8? So on the previous problem, they just said it's 2 standard deviations. Well, on this one, we have to figure out how many standard deviations it would be. So again, we're thinking about that standard normal curve, the mean being in the middle, the mean being 134.8, and that we are between 122.8 and 146.8. So like on the second part of that other problem that we did, we want to figure out how many standard deviations we are away. So what we're going to first of all do is just subtract the distance between those 2 points. So I'm going to take my 146.8, I'm going to subtract my 122.8. So again, if I grab my calculator here and do 146.8 minus 122.8, I get 24. Now again, the 24 is the distance from here to here, the whole distance. To do a standard deviation, I just want to be on one side or the other side, so I always divide that by 2, which means I end up with 12. 12 this way and 12 this way. Now we have to recall that in the problem it said 1 standard deviation was 6, and so if it's 12 each way, it's actually 2 standard deviations, because if I take 12 divided by 6, I get 2 standard deviations. So now the next part is going to be just like we did on the previous problems. We know it's 2 standard deviations. We're now going to throw it into Chebyshev's theorem and do our calculation. Well, this is the same calculation we had on the previous problem, because on the previous one we had 2 standard deviations. We're going to do 1 minus 1 over 2 squared, which is 1 minus 1/4, and we get 3/4 when we subtract that, which is 0.75, which then is 75%. So 75% would be the answer to the first question. The second part of that, according to Chebyshev's theorem, at least 36% of the measurements lie between how many mmHg and the other mmHg, rounding to 1 decimal place. So this one is the trickier one of the problems, because it gives you the percent and you have to work your problem backwards basically. And so I'm going to again use Chebyshev's theorem. I'm not going to worry about the 100 right away. I'm just going to start with this part right here. And I'm going to say that 1 minus 1 over k squared is equal to my 36%. 36% is a decimal, is 0.36. And that's where I'm dividing by the 100 that would have been in front of my thing. So that's the problem that I have to solve. And so I got to go ahead and solve that. First thing I'm going to do is move my 1 to the other side, so I've got to subtract my 1. And so again, if I grab my calculator here, 0.36 minus 1 gives me negative 0.64. So negative 1 over k squared equals negative 0.64. I have to multiply by the k squared to move that over to the other side. And so if I multiply by k squared, that's going to cancel that. I get negative 1 equals negative 0.64 k squared. And then I'm going to divide by the negative 0.64. So again, on my calculator here, if I take negative 1 and divide it by negative 6.4. Oops. I'm trying to use the one on the thing here. Okay. Clear that out. Negative 1 divided by 6.4 negative equals, I get 1.5625 equals k squared, and so then I have to take the square root of that since that was k squared. So now I'm going to do the square root of that, which is 1.25. So I am 1.25 standard deviations from the middle. One standard deviation was 6, and so I end up taking that 1.25 times 6 to see how many on each side that I'm on. So if I take my 1.25 times 6, I get 7.5. That means if I have my standard normal curve and my middle was at 134.8, 134.8, that I am 7.5 in that direction and 7.5 in that direction. So I have to add and subtract that 7.5 from my 134.8. So I'm going to take my 134.8 and subtract my 7.5, which tells me on this side I would be at 127.3, and then I'm going to take my 134.8 and add my 7.5, which gives me 142.3. So the range that I'm in between on that question then was 127.3 to 142.3. So that's the longer version of that problem, where you have the percentage. You have to figure out how many standard deviations that's equal to by solving Chebyshev's theorem. You multiply that number times how many one standard deviation would be, and then you have to add and subtract from the mean to see how far you are from both sides. Now, if I look at the next problem, part C problem, it says, suppose that the distribution is bell-shaped. According to the empirical rule, approximately 68% of the measurements lie between how many and how many mmHg. So on this one, we are just talking about our standard normal curve. Again, like we did on the previous problem, we know our middle is at 134.8, and we know according to the empirical rule that one standard deviation would be the 68%. So since it wants to know 68%, it wants to know one standard deviation from each side. Well, one standard deviation was equal to 6, so we know we're going to go 6 in this direction and 6 in this direction. So all we're going to end up doing is subtracting the 6 and adding the 6 to find each side. So if I take my 134.8 and I subtract 6, I would get 128.8. And if I take my 134.8 and add my 6, I would be at 140.8. So since I know it's within one standard deviation according to the empirical rule because it was 68%, I'm just going to add and subtract one standard deviation. Now if it would have been 2 or 1.25, then I would have had to do the same kind of thing I did up here, where I took my standard deviation times 6 and added it and subtracted it from the mean. Since it was just one standard deviation, 1 times 6 is still 6, so I added and subtracted 6 from each of those. So we got 128.8 to 140.8. All right, and then the last one here says, suppose that the distribution is bell-shaped. According to the empirical rule, approximately what percent of the measurements lie between 122.8 and 146.8. Now this is the empirical rule. And so again, first thing we have to do is figure out how many standard deviations we are from the middle. And so it's basically going to be the exact same process that we did up here, because you'll notice they use the same numbers, but I'm just going to go through that again. And so if I have my bell-shaped curve and here's my middle, I was at 134.8 for my mean, and I want to be between 122.8 and 146.8. So what we did is we subtracted the 146.8 and the 122.8. So 146.8 minus 122.8 gave us 24. Now when we subtracted that, that's the total distance between those two values. We want the mean to be in the middle, so the first thing we're going to do with that number once we subtract is divide it by 2, which means we're going 12 this way and 12 this way. We're going to take that distance and we're going to divide it by what one standard deviation is. One standard deviation was 6, so 12 divided by 6 means we're at 2 standard deviations, which is the same thing we got up here when we were doing the empirical, or the Chebyshev's theorem. Now we're doing the empirical rule. So the empirical rule is a lot easier. If we know it's within 2 standard deviations, then we just look over at our chart and we say, okay, 2 standard deviations means 95% lie within 2 standard deviations. So on this question, we say 95%. So most of your problems will be like part A and part D. The next one's probably part C. You won't have a whole lot of part B, but if you do have part B, those are the longer ones where you have to do that whole entire formula. So hopefully that helps you out a little bit when you're trying to do those. It should cover most of the types of questions that you're going to see when you do Chebyshev's theorem. And so let me know if you have any more questions.